Arshita? Good morning, Naveen ji. Am I audible, Naveen ji? I think your mic is muted.
Yeah, it is audible.
Okay, fine. Can you give me 2 minutes? We will start this.
Good morning, Naveen ji.
Okay. Yeah, good morning. Just a minute, I will be coming, please.
Naveen sir, we are starting the program. Happy Sankranti to all. This is Ashok Kumar from CMTA. On behalf of CMTA, we are organizing a wonderful lecture on soil testing. Today with us, Dr. Naveen is there. Welcome to this program, sir. And my colleague Nayana will introduce about Dr. Naveen in detail.
Hello.
Is going to explain. Yeah, Nayana, over to you. Yeah.
Good morning to one and all present here. Welcome to today's session. I am Nayana B, Civil Engineering, passed out from MVJ College, Bangalore. Presently a student at CMTI. On behalf of Construct Management Training Institute, I welcome all for today's session on soil testing important. Construct Management Training Institute is a professional organization working towards development of construction professional through structural training programs through experts from construct industry. Construct Management Training Institute is founded by engineer S.G. Ashok Kumar, seasonal project management professional having strong expertise in project management and worked for leading companies like L&T, JMC and many more. CMTI has strong advisory board with experts from the industry. For more details, visit www.cmtionline.com. Construct Management Training Institute has trained 5,000 plus students on various training programs and placed 1,000 plus engineers across India on various domains of construction. CMTI has training programs for working professionals also. CMTI is official technical training partner of Naradco, Karnataka. CMTI is associated with various professional organizations like ACCE, IGBC, etc. As we all know that today's session is by Dr. Naveen BP, it's my pleasure to introduce this sir. He completed his MTech from National Institute of Technology, Karnataka, MS, PhD and postdoctorate from Indian Institute of Science, Bangalore in Geotechnical Engineering. Sir has 14 years of diverse from progressive experience in the field of geotechnical engineering. Geo-environmental engineering, metro works, waste management, and ground improvement. Sir got an Aqua Foundation Academic Excellence Award for Solid Waste Management in 2016, Oasis Project of Year 2016, and 25 paper in journals in this 3 research proposals submitted. Sir got an Hang Educated and Scholar Award 2017 and 2018, IEI Young Engineers Award 2018, Professional Excellence Award 2018, nominated as Heng Geotechnical Engineer 2019. I welcome you, sir. I welcome audience. If you have any doubts, you can leave message in chat box. We heartily welcome you, sir. Over to you, sir.
Thank you, Naina. It's
My
over, Naveen.
yeah,
Dr.
yeah.
Naveen,
Thank you.
it's over to
Yeah,
you. Thank you. Audience, if you have any queries, you can write in the chat box.
my slide is visible.
Yes, sir.
Yeah, I want to make in a bigger size. Just a minute, where I am unable to make it.
Yes, you can proceed.
Just a minute.
Sure, sir. Sure. Sir, can you charge your laptop? I think 30% is there.
Yeah, it is charging.
Okay, fine.
Is it visible now in bigger size?
Yes, sir.
Is it now? Is it okay?
Yes, sir. Please, sir. Your video is not visible, sir.
It's okay. Audio is sufficient.
Okay, okay.
Okay. First of all, I should thank to Ashok and CMRI for organizing this wonderful session for the young budding engineers. And today you have requested me to deliver a wonderful topic that is on soil testing for the constructions. First of all, you should understand why this soil will play a major role in the construction. And you have requested me to go from very basics, types of soil and its applications for the construction purpose. So keeping in that mind, I have prepared my slides accordingly. So any engineer, any civil engineer or anyone who is trying to understand the soil mechanics or importance of soil construction, you will can learn that in a very short time. And if you are able to concentrate very this type of basics, first of all, you should understand why the soil term, where it comes. All these things I will be trying to cover in this 1 hour session. The soil term that is always derived from the Latin I told, and it is the word is called as anosolium, which means that upper layer of the earth surface. So just a minute. So when you are, this is the outline of my presentation. Today I will be discussing the terminologies of soil, formation of soils and types of soils, and the field identification test when you go for the site. And now you are a budding engineer, so you will be going to the interview, or if you go to the suddenly for the site, someone may ask how to differentiate the sand, silt, and clay, or if they are asking how to identify the soils. So you should be have some thumb rules. Spontaneously, you should able to identify and answer the questions. Or if like a labor may ask, sir, what is the, can I terminate the depth of the borehole, or can I stop the boring? As a site engineer or a design engineer, whoever may be, first you should try to take the soil and feel that what type of soil exactly, and whatever it is coming in the soil report or whatever you are getting at your current location when you are doing the drilling, both are same or not. You should able to interpret spontaneously and give the decision. There, this field test will play a major role. Then sieve analysis to make that type of soil exactly, sand, silt, or clay, how much percentage, and you will be telling whether it is in a coarse grind or. Then for construction purpose, another major field test is bulk density. To calculate that, we will be going for the sand replacement method. Then another is there, compaction will plays a major role. Then plate load test, then pile load test. This session, I'm just only touching the main field uh, testing. These are the very important test. I'm not discussing about the laboratory test that I will be covering in the next session. So first of all, you should understand, if you ask any, because soil is not only interacted by the civil engineers, the soil is also interacting with the agriculture people, as well as geologists also, as well as engineers also, civil engineers. Suppose if you ask the question of soil, how they will relate, if you ask the agriculture, you may say like this, it is a loose surface material of the earth, which is used for the plant growth. We will think only in this perspective, in the top layer. But when you ask the geology person, what do you mean by soil? He will say like this, it is the material which is produced as a result of the disintegration of rock and which has not been transported from its original position. So, and if you ask the engineer, like a civil engineer, he will say soil is an uncemented accumulation of the mineral of organic particle occurring in the zone over the layer of rock crust. That's why soil is a term, it will be used by every specialized person. It is a multidisciplinary. Agriculture people will go in depth like a soil chemistry, they will try to understand pH, other things for the different types of crops. But civil engineers always use this in the form of evaluation of strength behavior, like calculating their bearing capacity. To calculate the bearing capacity, first you will be understanding their strength classification, whether it is any compressibility, high compressibility, low compressibility, or what is its density, specific gravity, and what is this permeability value of each soil will have a different characteristics, and and you will be conducting a engineering strength to calculate the engineering properties like a direct shear, triaxial for a different conditions. But agriculture people will do only very basic test and they will concentrate according to the soil chemistry part. But civil people will also do the few test common, and their objective is to concentrate on the engineering aspect. So that's why this you can see this is the top layer is will be decomposed and this will be the soil. It always depends on the parent material it contains of the minerals, and this is the bedrock where the soil will be formed. That is the like a residual soil as well as transported soil. Before going to the soil formation, we have to understand how soil is formed. The soil is formed by weathering of rock only, and this rock is classified according to these three major categories: igneous, sedimentary, and metamorphic. If rock should be formed, this is the process of the rock cycle. First is magma. This is called as an internal. This is called the interior of the earth is called as a molten state, and that is called as a magma. Then rocks are formed due to the cooling of this molten, and this rocks is broken down into soil, and the soil will be converted back into the rock. This is the cycle called geological cycle. This is called geological cycle. It will take these 9 steps by magma, crystallization, igneous rock, erosion, sedimentation, sediments and sedimentary rocks, then tectonical mural, metamorphic rocks, and melting. This is the formation. See, I told the soil formation again is derived from this parent rock because of this weathering action. This is physical weathering. It may be due to wind, rain, thermal expansion. And chemical weathering is nothing but water, acid, and gases. And biological weathering because of this plant roots, everything. You can see if you want to get 2.5 centimeter of rock, it will take 200 to 1000 years. It will take time, long time. See the duration. That's why I was telling. Now, this is the rock formation. The main thing is always the parent rock. Parent rock, from the parent rock only, the soil is derived. This is the two major thing. One is called residual soil. The residual soil is nothing but the soil which reside at this original place only. That is called residual soil. And this is affected by the physical and chemical of the parent rock. And similarly, the transported soil is nothing but the name only is indicating it is in a moving and deposited to the other place. The agencies are by wind, water, and ice. And this is the 5 major interacting factor that affects the soil formation. So, first of all, you should understand if soil is getting a red color, black color, or if the thickness is, when you do the bore law, thickness will be keep on varying. It may get 2 meters soil, sandy soil, then 3 meters clay soil. Why and what? All this all because of the factors affecting. This is the 5 factor parent material that contains the mineral forming of the soil. See, this will determines this color, chemical property, mineral content, and this permeability. See, if it is a sand, silt, or clay, all these have a different permeability, different mineral. This all derived from this original parent rock. That's why I discussed the background behind that. You should understand how soil is formed. Then this is the living organism. This is influence the soil formation. And also with respect to time, the layer also decided. If layer is 2 meter, 3 meter, when you think all will be decided by the this. And also topography. This will decide. This is topography is nothing but the slopes, grade of the slope affecting the drainage, erosion, deposition. All this will be again. And climatic condition. This affects the rate of weathering and organic decomposition. All this. See, if soil should come, this is the 5 important interacting factor affecting the soil formation. Now, when you are coming to types of soil, you have 6 types. Sandy soil, it is large in particle, dry and gritty, and having high permeability, If you are talking in a geotechnical, it may say as per the thumb rule 10 power of minus 4 it will come. And silt, it is a very smaller particle than sandy material, moisture retentive and drying poorly. And when you touch, you will have a soapy structure when wet. And the clay, it's compared to this, it's a very fine particle and have a good water storage quality and low permeability. Here, the permeability value will be 10 to the power of minus 6. Here, it will be having 10 to the power of minus 9. This all will be how I am telling minus 5, minus 9, minus 4, because as a civil engineer, we used to perform a permeability test. That basis we can able to differentiate the permeability, and based on that we will be recommending for the construction purpose. And the behavior is sticky behavior when wet and smooth when it is dry. And its speed, it looks like a dark brown and black in color, and have a high water content and rich in organic matter. And saline, it is in a wide surface because it is in a short crystals and bad for the plant growth, and dry due to the high salt content. And low medicine mixture, ideal soil for the growing. It is a mixture of sand, silt, and clay proportion as a uniform soil texture. And has a right permeability and water holding capacity. That's why it is good for the agricultural or a plantation purpose. See, if you see now, we will be going to discuss particularly on civil engineering aspect. Now, we are not talking about the course. Now we are only coming to the fine. See, soil, if you're telling, it will be range in the pump 0.05 to 2 mm. You can see this is, and silt, it will be 0.02 to 0.05 mm. And clay, it is less than 2 micron. When you compare, sand is in a largest, you can see. Silt, when you compare, it is less than sand, medium, and clay, always it is less. And this, so you can see this voids. This is the largest, that's why voids are there, and it is high permeability. And this is the clay particle and have a low permeability. That's why it clearly defines. Now you are coming to major parts of the if you see this India map, you can see we have 6 types of soils found in this India. This is forest mountain soil on this top, Jammu, Himachal, this side, and alluvial soil, red and yellow soil, black cotton soil, lateritic soil, and aeric soil. This we will be understanding one by one detail. And you can see this. This is called alluvial soil. This soil is transported from its place of disintegration by the flowing water, and it is deposited along the steel. It's known as an alluvia. And this soil contains a lot of minerals and humus, and which makes the soil fertile. You can see, and this type of soil will be identified in the Punjab, Haryana, Assam, UP, and Bihar. Next is this is the black cotton soil, and this is also known as ridges. And this they are black volcanic soil and found largely in Karnataka, also in Raichur, MP, Maharashtra, and southern Gujarat. And this soil is quietly suitable for the cotton. And this black cotton soil are highly expensive soil and not suitable for the construction purpose. See, this is desert soil. Desert only you can see the picture. It's having a very fine sand and found largely in the Rajasthan. The color of its type is yellow because it is formed by the weathering of yellowish rock. That is called sandstone. These are not suitable for the growing of crops. Now coming to the red soil. And the red soils are generally found in the Karnataka, Orissa, Tamil Nadu, and this in southern part of Karnataka especially, and southern eastern part of Andhra Pradesh, Manipur, Mizoram, Meghalaya, and Nagaland also. And these are derived from the acid gravities. And red soils are always rich in the potash and are poor in the lime phosphate. And these are mainly because of siliceous and aluminous with sand and free with quartz and its chemical composition. The red soils are not very fertile. Red color of the soil is not due to the high iron content, but it is due to the white diffusion purpose. This red color is there. And mountain soil, or we can call as a hilly soil. This mountain and valley of hilly. This you will see in the Kailash Maharaj, southern hill, and it is covered by the hill soil. Dissolved by the loose pieces of large rock present in the slopes, rock downs, and settles in the riverbed and slowly converted into mud. And this is lateritic soil. The term lateritic means red rock or red earth. Laterite are formed by the decomposition of different kinds of rock. You can see this. This we will be seeing in the Mangalore under the condition of yielding of alumina and iron oxide. The main reason of lateritic soil formation is due to intense of leaching. These soils are developed by the summits of hill and uplands. In India, they are mostly found in the Kerala and especially in the coastal area, especially in Mangalore, Tamil Nadu, Maharashtra, Chhattisgarh, and hilly areas of Orissa and Assam also. And this is saline alkaline. The name only it contains because it is interacting with the seawater. It contains salts like a sodium, magnesium, and calcium, and it is infertile, unfit for the cultivation. Next is peat and marshy soil. This occurs in humid region and it is formed by the accumulation of organic matters. And this will be in the black in color with high acidic and heavy. And this type of soil you will be seeing in the Kerala, especially in the Kottayam, Alapi. And this is marine soil that is formed from the material that is carried into sea by streams and by the material eroded from the beach by the tidal action of the waves. The part of the material is carried out and deposited in the deep water. The part is heaped upon the beach along the coast. You can see this type of sea in the marine coastal side. And this is alien soil. This is transported from one place to another by wind. That's why this sand dunes you can see. This is all transported. Loam soil is a made for the balance of three main types of soil. That is when you call sand, silt, and clay soil. As generally says in the thumb rule, the loam soil should be of equal parts of all three. This combination soil type creates a perfect soil texture for the plant growth. And glacier soil is a carrying with some soil with varying size from the fine grain to huge boulder. And the soil get mixed with ice and transported far away from the original position. And drift is generally termed used for the depositions made by glaciers. See, now we have understood the types of soil. Now we have understood the types of soil. Now, as a engineer, anyone, if you go to the site, you should able to tell properly what type of soil. Now you understood type of soil, what is the mineral. Like for that, if you are going to the site, you should able to predict. See, you can see different. You should able to at least uh, do the proper recognized survey, and you should able to predict it in spontaneously. So that's why identification of soil types in the field is limited to defining the color, texture, and plasticity, and done without benefit of major equipments. So taking the soil to the laboratory or conducting in situ test, it will require time and money. But it is like instantaneously you should take the decision when you're making the boring or when you're terminating the pile depth. So this knowledge is very essential. And it is necessary to do general assessment of the site during the field reconnaissance survey and during the initial phase of work. Suppose uh, borehole won't be done in all location. They will be doing only in the particular location. In entire in 60/40 site, they may done 2 boreholes, but your foundation is coming in different location where borehole has not done. But the foundation is designed based on the borehole only, soil profile. But you should be cross-checking whether that soil and when you're drilling is coming correctly or not. So this type of field testing will plays a major role. Sometimes this test may be sufficient for ordinary work, but in most cases it will be serve as. See, small work, this can be done. And detail and precise identification required laboratory testing. See, if you want to predict exactly what is the strength, how much permeability, compressibility, all this exactly specific. Then you have to collect the disturbed sample or undisturbed sample. Then you will take the sample to the laboratory and do all types of testings. See, when you go for a visual testing, how you will do? By looking at the soil, you can make a distinction between the gravel, sand, and fine. How? When you're calling a fine, again, it will be combination of silt and clay, both component. However, silt and clay particle cannot be separated without further magnification. The examination will be done by drying a sample, spreading it on the flat surface, then simply segregate it into the various components. This is a visual. When you touch the soil, you will get the feel. If it is in a rough and gritty, then it will be sand. So then you will be doing a sedimentation or dispersion test. This test is done by shaking the portion of sample. You're taking a soil sample, putting in this glacier and shaking it, and you keeping allow it for some time. Gravel and coarse sand will settle fast, but fine sand will take 30 seconds to less than 5 minutes. And silt may require much as about hour. Clay may shall remain suspension for several hours. Means coarse particle like gravel and sand will settle fast, but silt will take at least 1 hour. But clay, I told, it will take long time. Based on this, you can see the percentage of each component is estimated by comparing the relative thickness of each of the layer in the bottoms. That is when you're calculating how much percentage that you can calculate. And one more thing is if you want to calculate the plasticity, in this test, you're taking the soil and have a press between your thumb, so you can see, and make a 3 mm thread. If soil can be rolled into 3 mm thread with no crack in the sample, that is clay soil. First, you'll be making like a small ball and you're making a 3 mm thread. If there is no crack, then it is a clay. If soil rolled into 3 mm, but cracks develop on the surface of the sample, then it will be silt or silt with clay. It means that silt percentage will be higher than clay. If soil cannot be rolled into 3 mm thread, then it clearly show that it is a non-plastic. It may be sand only. Now you are checking the toughness. This is a dry strength or breaking test. What you will do, you will prepare the soil pad and attempts are made to break the dry pad between the thumb. So you are doing like this. If doesn't break, it means that have a very high plastic clay. If it is break with a great effort, it is a plastic clay. It can be broken and powdered with easy, then it is a silt or silt with clay. If crumbling or powdering will occur while being picked up by that, then it is a silty sand. So this is all simple things. You can do it in the site immediately. Then you are doing the shaky test. You are taking the soil sample, putting in the palm and folding it. The hand is then shaken vigorously, and in between stricken against them. You can see if the surface become glossy like this, by rising of moisture to the surface and squeezing between the finger, glossy appearance quickly, it is a silty, that is an indication of silt. If the process of appearance and disappearance of moisture, which is called slow, then it is called as a silty clay. When the reaction does not occur, then it is a clay. See, this all simple thing you can do. Then next is wet test. Here also you will be taking a pint of soil on the palm, adding a water and rub it between the thumb. If soil give a soapy touch and stick to a finger, then it is a, you can call clay because it's have high plasticity. That's why. And it doesn't give soapy touch and doesn't stick to the finger and dries quickly as a silt, then it is a silt. If it gives a rough feeling and no sign of wetting appearance, then it is called as a fine sand. Then soaking test. You're taking a small lump of soil in the glass container containing a pure water. Observe the lump disintegrated in the water. If the soaking and disintegration take place quickly, then it will be silt or clay of low plasticity. If soaking and disintegration take place very slowly, then definitely it will be a clay with a high plasticity. See, these are all the things you can see. If you see there also in the gravel soil, mix with water. If you do molding, because whites are moved, it won't. It had no plasticity, so it will no slump will be prepared. Sand also little because having light plasticity, very low plasticity. Silt will have a good cohesion. Clay, see, is a very good cohesion because of high plasticity. You can see this is the simple test you can perform in the field immediately. After understanding the silt, clay, and this, now if you want to do the proper characterizing how much percentage of silt, how much percent of sand, how much percentage of clay, what you will do, you have different types of sieves like a 4.75 mm, 2.36, 1.18, 600 micron, 300 micron, 150, 75 micron, then it is in a pan. First, you will be taking the soil sample. First of all, we should understand why do we do the sieve analysis? What is the benefit? The sieve analysis always determines the particle size distribution of the any given sample, and also it helps in easy identification of the soil's mechanical property. This mechanical property will help to determine whether the given soil can support the proposed engineered structure. Okay, this is first of all you should understand, and also by purpose of this test is to determine the percentage of different grains contained. See, this is in a mixture. If you want to know exactly how much percentage, that's why this test is performed to determine the percentage of different grain size contained within the soil. The mechanical or a sieve analysis is performed to determine the distribution of coarse, large size particle. And for finer size, we used to do hydrometer test to determine the distribution of finer particles. See, first you will be taking the soil and you are putting in the sieve and shaving for a 15 minutes. This is the sieve saved. After that, you will be weighing. And you will be weighing that each sieve. This is called soil retained in the each sieve. Then you will be calculating the percentage retained. Then you will be doing cumulative retained. Then you will be doing percentage final. See, this is the curve. Generally, we will get three types of curve, like a poor grade. You can see this is gap grade. This is uniform graded and well graded. For a construction, we always use well graded. If it is having only one type of soil, it's also danger to use in the construction. Always it should be in well graded. See, if you want to understand the specifically for the if it is sandy soil, in sand you have a three types: coarse, medium, fine. Gravel you have a coarse, medium, fine. In silt you have a coarse, medium, fine. Then less than 2 micron is clay. You can see for silt and clay you will be doing fine hydrometer analysis. Then you will be generating this portion curve. You can see for a gravel sand, if you are doing the test, so you can see gravel is percentage is more, then followed by sand. The shape will be like this. This is clayey gravel with sand. You can see it is a fine sand. The shape of the curve. This is based on the literature you will be getting. See, now we are trying to understand why this field density, especially calculating the bulk density, will play a major role. As you know, the dry density of the compacted soil, and this generally we use for the pavement construction of road purpose. The dry density of the compacted soil or a pavement material is a common measure of the amount of compaction achieved during the construction. And also, therefore, the field density is important as a field control test for the compaction of soil or any other pavement layer when you're making. So especially for the sand replacement density are used to measure the in situ density of natural or a compacted soil using a sand pouring cylinder. See, this is the cylinders. This is the 3-liter capacity shutter. This is the cone, and this is the calibrated container. 10 centimeter internal dia, 15 centimeter internal depth, and 5 centimeter flange. This is metal tray. How you will perform, we will see. First, you are taking the sand, you are passing 600 micron, which retain on 300 micron you will be collecting. Then you are calculating the volume. This is the formula. Then you are filling the sand. Then you are measuring. That is called W1. Then you will be putting this in the cone. Then you will again, after filling this, you will take this and weigh this. This is W2. Then again, you will check the how much cone. Again, you will put it in the tray and you leave the sand to retain. That will be W3. When you deduct all this, you will get this weight, WA, weight of the container. Next, same thing only. This is called W3, which I was telling. To check this cone, this is called W3. When you deduct, you will get this WA. And now you want to calculate the bulk unit weight of the soil. So what is the formula? Weight by volume. So now you already WA, you calculated, you know the volume, you will calculate the sand. Now what you want to check it in the field. First you will do 15 centimeter excavation. You will put the tray, you will excavate. The excavated soil will be collected in this tray and you will put the cylinder there and you will make the soil to fill. So you can do excavated soil you are measuring, and also you are measuring this sand container, that is W1. Then when you are filling, this is this. After filling, you are just removing and putting on the weighing machine, you are measuring. Similar way, how you did W3, same thing we have doing. This is the cone. When you deduct it, you will get W poured soil. Okay, now you are calculating. You already know the density. Now you are calculating the volume of the oil. Whole, how much? So to calculate the volume of the whole, you already calculated the weight of poured soil and the density you already know. When you divide, you will get the volume of the whole. And you know the weight of excavated divided by this volume of the whole, you will get the bulk density. After, if you want to calculate the dry density, what you will do, whatever the soil which you are collecting in the tray, you will be conducting moisture content test by oven drying method or a pycnometer, sand bath method, rapid moisture content. Any method you can do it and calculate the moisture content. Once you calculate the moisture content, just substitute. This is the bulk density, 1 plus water content, you will get the dry density. See, this is the, you will get the dried. Now you are coming to the compaction. First of all, you should understand why the compaction plays a major role, especially in civil engineering projects. In the construction, especially in the construction of highway embankments or earth dams or many other engineering structure, or a loose soil must be compacted to increase their unit weight. To compact the soil to place it in the dense state, the dense state is achieved through the reduction of air voids in the soil with little or no reduction of water content. Actually, this process must not be confused with consolidation, in which the water is squeezed out under the action of continuous static load. Here you can see the compaction. When you do the proper compaction, it increases the strength characteristics of oil, which increases the bearing capacity. You can see this is the poor compaction. When you do proper compaction, the bearing capacity has increased and increased the durability also. When you do, this is a poor compaction. When you do good compaction, higher resistance of to deformation, higher resistance to frost damage, and also when you do, this is a poor compaction, This is a good compaction. How you can see the differentiate. When you do the good compaction, it will increase the stability and decrease the permeability. Means whatever the voids present air, it will be closed by doing proper compaction. And also the purpose of doing compacting soil is to increase the strength, reduce the permeability, and reduce the compressibility, control this swelling and shrinking, and reducing the liquefaction potential. See, this is the standard Proctor test we are using. The diameter is internally 114 on the collar. This is 101.6 mm. This is mold, and height is 116. This is the height of the rammer, 305 mm. The diameter is 5 now. This is the compaction mold. First, what you will do, soil, when you take the soil, it will be like before like this. When you do proper compaction at each layer, you are taking the soil and dividing in the each layer. This is the 2.5 kg hammer. Each layer you are blowing 25 blow. See, first you have to blow in this direction, 1, 2, in all direction. Then in each blow, this is the process of successive. The energy is dissipating and soil is getting compacted. See, initially it will be like this. When you do proper compaction, soil before compacting, it will be particles will be like this. When you do proper compaction, the soils are completely packed. If you want to understand better way, you can see this is the loose soil. So much voids are present, air and water. When you do proper compaction in 3 layers, this is the compacted soil. Then you are able to achieve the dry density after getting 6. They have done for a 6 trials. This is called maximum dry density. This is a OMC. This is a zero air void lines. It observes that the dry density increases with increasing the water content. See, with increasing water content, dry density also increase till the maximum dry density is achieved. After that, it will start decreasing. And further increasing the moisture water content, the density start decreasing. Zero air void lines means the curve is nothing but saturation line. This curve represents the full saturated condition. It means that it's equals 100%. It cannot be reached by the compaction. Theoretically, we used to given this formula to calculate. See, now we understood the standard Proctor. Now we have to know modified Proctor test, and this test was introduced by US people, and it was developed during the World War II by the US Army Corps of Engineering for the better representation of compaction required for the airfield to support the heavy aircraft purpose, because the dynamic load is huge there. See, this same procedure here you will be doing 5 layers. You are putting high energy. There you are using 2.5, you are using 5 kg hammer. See, you are making you are putting the soil and you are doing the compaction 1, 2 in all circular. The mold is also bigger here. And when you compare standard compactor with compactor, density is high, moisture content will be less because the more energy. Now, when you are talking about the realistic in the practical scenario, if you see when you're traveling anywhere, you will see the different types of roller compaction equipment. Generally, you have it 4 types of equipment will be used for the compaction. One is smooth wheel rollers, pneumatic roller with tired roller, and sheep foot rollers and vibratory rollers. You can see this is the compaction equipment. This is smooth wheel rollers are suitable for the proof of rolling, subgrade, and for the finishing operation of fields with sandy and clay soils. It will be used, and these rollers provide 100% of coverage under the wheels with a ground contact pressure of as high as 310 to 380 kilonewton per meter square. They are not suitable for producing high unit weight of compaction when used in a thick layer. If they are using, see, this is smooth fit roller. You can see this is in a single drum, and this is in a two drums. And this is effectively mainly for the gravel, sand, silt, and the soil purpose. And this is pneumatic rubber tire rollers. These are better, mainly respected than smooth wheel roller. The former are heavily loaded with several rows of tires. The tires are closely packed, spaced for 4 to 6 in the row. Pneumatic rollers can be used only for the sandy and clay soil compaction. Compaction is achieved by the combination of pressure and kneading. You can see this type of rollers you have seen, but now you are understanding why, and also suitable types of rollers should be suggested for the suitable soils only. You can't use randomly. And also this is sheep foot rollers. During this compaction in the field, the initial phase compacts the lower portion of the lift, the compaction at the top and the middle of the lift, done at the later stage. You can see this type. And also this is called vibratory or extremely efficient in compacting granular soil. And vibrators can be attached to the smooth wheel pneumatic. So you can see it is a tire plus drum. This vibration produces the rotating of central weight. See, now you understood the compaction. Now we are coming to the penetration test. See, why we want to do the standard penetration test. It will tell about the thickness of the layer, and also it will spontaneously tell approximately based on the N value, you can judge it, the strength of the soil. So, and the cost is very less. Suppose if you want to take the soil and do the test, it will take long time, and it will financially also there. It's an immediate test for see, you can see this is the first you will be identifying the borehole. This will be 150 mm dia. Then you will be putting the drill rod at you are making the hammer to follow, that is 65 kg. At 75 centimeter height, you are making to fall in a just to penetrate 15 centimeter. If it is N is, and based on the 15 blows, if N is, this soil is defined based on the N values. If it is N is greater than 50, then it will treat this as a rock. And also once you taken the values, then you will be doing the proper correction should be there. There will be no correction for the cohesive soil and the correction for the load burden pressure and the dial. This is given in the code book. This will be the corrections applied for the cohesion less for sandy soil. This is the, we can't use the values directly, whatever we are getting from the SPT value, because errors will be there. I will be showing the errors. See, this is the correction factor you should, overburden correction should be applied, and you are using a different types of hammers. So you should apply that type of hammer corrections. Then diameter of the borehole. Suppose if I'm using a diameter bore, I should apply the correction, then rod length, then sampler, whatever the things. Then only after doing all the correction, then you will get this corrected N value. This will be N60, 60% of energy. That's why N value, what we got, Cn, Ce, Cb, Cr, Cs. This all is nothing but correction factors. All this. Cn is nothing but overburden pressure. This is energy ratio, borehole diameter correction, rod length, and samplers. Once you apply, then only you have to use this value. You can't use directly a raw value what you are getting from the SPT. This SPT will be done at every 1.5 meter depth. And also to calculate the ultimate bearing capacity of soil, we used to conduct a plate load test. And this will be divided into 3 steps, like a test setup, test procedure, interpretation of result, and limitation. First, this test can be done in the 2 method. This is called gravity method, and this is called truss method. First, you are creating the pit 1.5 centimeter. Then you are putting the sandbags. This is the steel plate of 60 centimeter or 75 centimeter. Then with the jack and hydraulic pump, you are applying the load. You are transferring to the soil at required load. You will be transferring, and you are calculating the load settlement curve. See, this is the platform for gravity, and this is, instead of going for this, you can go for this is truss method this way. See, for different type of soil you will get. For cohesive soil, you will get this type of curve. If it is in a soil with a loose to medium, the cohesionless, you will get this type of soil. This is an I am showing this picture for different types of soil based on the literatures. So this is, if it is in a soil, is a dense, then you will get an exact curve like this, dense cohesionless soil. If it is in a partially, you'll get like this curve. Based on the curve, this is you can indicate the type of soil you have. And also this plate load test have a limited limitation. Like this test reflect only to the character of the soil located within the depth of the less than the twice the width of the base plate. Because when you are applying, the pressure bulb will be created that 2 times the dew only. So this is the limitation, and the plate load test being of short duration does not give an ultimate settlement, particularly in case of clay soil. That's why with this test is recommended for the sandy soils. For clay soil, the bearing capacity for the large foundation is almost same as the smaller test plate. In dense sanding, the bearing capacity increases with the size of the foundation, and hence the test with a smaller test plate tends to give a conservative value, especially in dense sandy soil. See, this is all the limitation for the plate load test. So when you are a designer, when you are recommending, you should be very careful. Now, plate load test will be done for the shallow depth. Now we will be doing this for deep foundation for a deeper depth. We will be going for the pile load test. In pile load test also you have a different type. Same thing, gravity test, gravity loading. This is the sandbag. You are also just this is the pile. You can't able to. You can see this pipe is going. This loading is done by the sandbag. This is called hydraulic pump. Gauge is there. This hydraulic gauge is applied on the pilot. For more accurate, you are putting the dial gauges in all 4 directions and load is applied and you are waiting for 2 hours and or the rate of settlement becomes 0.2 mm per hour, whichever is early. Till that you have to apply the load and you should wait for 2 hours or the rate of settlement will become 0.2 mm per hour. See, this is another method. This is called girder, anchor girder or reaction pin. The equipments we are using in this method is hydraulic jaw, test pile, anchor pile, dial gauge, and reaction truss. Same thing. See, first the reaction girder or anchor girder is doing at 1.5 times or 2.5 times CD. See now, this is this truss method. In soil also we have did, for a deep also same concept. The objective is to transfer the load. See, then dial gauges are fixed. Hydraulic jaw, you are applying the load. This is the hydraulic pump. It will be compared and 3 to 4 dial gauges will be fixed to check the deformation. At each stage of the loading is maintained till the rate of settlement movement of the pile is not more than 0.1 mm per hour in sandy soil and 0.02 mm per hour in case of clay soil or maximum 2 hours. Under each load increment, settlements are observed at 0.5, 1, like a different 16 minutes, 20 minutes, like this. The load should be continued up to twice the safe. It means that 2 times the D. Suppose if you have a 10 tons, you should apply the load of 2 times the D. It means 20 ton, at which the total settlement reaches the specific value. Then load is removed in the same decrement at 1 hour. If you are making a loading unloading, then you will be doing. The final report record is 24 hours after entire load has been removed. Then you are plotting. See, they were telling like this. Each load you have to apply, leave it for 2 hours or 0.0 mm. See, this called is a loading curve. And when you remove the load, it will come. This curve is called unloading. This is loading and this is unloading. After doing that, you can able to calculate the net settlement. This is the total settlement minus elastic settlement. From that curve, you will get the net pile settlement. From the result, you can see ultimate load of the load settlement curve becomes either linear or this or the sharp break as curve as shown in the figure. You can see this. Sometimes the curve won't not linear. Then you can use the single abscissa, double abscissa method to do that. And also as per IS 2911 will say, the safe load should be taken as 1/2 of the load at which the total settlement will be equal to 10% of the dia. And also second condition, they will say like 2/3 of the final load at which the total settlement is 12 mm. And third one is 2/3 of the final load, which causes a net settlement of 6 mm. See, when you are conducting the load test of pile, you should satisfy this condition, any of the one condition. Then only your results will be accepted. Thanking you.
Yeah, thank you, Mr. Naveen,
Yeah. Thank you.
for your time in your busy schedule and in short notice. You were available for our students.
Yeah. Yes. Now I have meeting.
Yeah, you
Uh,
have, I understand. That's the reason I wanted to leave you. The questions we will take in the next session. Anyway, we are going to conduct next session. On that time, we will take the questions.
no problem.
Since you are going in a hurry for a meeting, and I thank wholeheartedly from CMTA to sharing the knowledge with our students.
And thank you, especially Ashok. I really appreciate you and your team. People are really understanding the students' mindset, and you are giving the right platform for the students. You are taking their feedbacks very clearly, and spontaneously, people are reacting. And you are identifying the every speakers. I used to see your updates. I really happy that even when
Wonderful.
I was pursuing my bachelor's or anything, we didn't get this opportunity, but you are doing wonderful job for the youngsters. Keep doing this, and if you need any support from my side, you please feel to discuss anytime.
Sure,
And
sir.
I thank everyone, and especially I thank you from my bottom of my heart for giving this opportunity and sharing my knowledge to the youngsters. And
Yes,
if
sir.
you have
It was
any,
very interesting. I saw all your PPT. Wonderfully, you have explained with the basic things, which a side picture and a theoretical picture and an explanation. Easily, they can grab the things. That's I
because
liked really the program.
yeah, because you told me because students are confused about soil, you should
Yeah.
give the glimpse. That's why I have taken time and I prepared it from the very scratch from them.
Yes, sir. I can see your efforts on that.
Thank you. And end of the day, they should be benefited. That is my
Yes, sir.
and
Yes, sir.
thank you. And you're doing good job. Keep doing, sir. Thanks a lot.
Yes, sir. Yes, sir.
Thank you. Bye
We will
bye.
meet in some other program. Okay,
Thank
sir.
you.
Thank.
Bye.
Thanks for the audience for joining this program. We
And
have a wonderful program in building information modeling tomorrow at 4 p.m. You can
okay.
join.
Thank you. Thank
Okay.
you.
Thank you, sir.
Thank you. Bye bye.